Hello everyone. Today we will start reviewing Unit 8. Unit 8, it's about material changes. In the previous unit, also we talked about the types of materials. Today we will see how these materials it changed. Firstly, we have two types of materials. We call them acid and alkalis. Acid and alkalis. Acid and alkalis are liquids. Both of them are liquids. Then, to differentiate between them, acids have a sour taste. Alkalis have a soapy feel as they react with fat on the surface of the skin. They are not tested to try at the laboratory or at home. It means because they are dangerous, so you should not test them or deal with them at home. Although some of them we can use it at home, but we will see not all of them. Now, both acids and alkalis, can be corrosive substances, and can burn the skin severely. If you will use these acids or alkalis, especially the strong one, it will burn your skin. But as I mentioned, still we are using some of these acids and alkali at home. Firstly, indicators. The word indicators, or what do you mean by indicator? Indicator is a chemical liquid, that it gives different colors when it will be mixed with acid or alkali. How is that? Definition, you need to memorize it, is a liquid which produces a particular color if it's mixed with an acid or alkali. For example, if you will take a look on this, these are examples of indicators. We have red cabbage, litmus solution, methyl orange, and phenolphthalein. These are examples of indicators. Now, here, as we said, it gives a specific or a particular color when it mixed with acid or alkali. We will see how. If you will have a solution and you don't know this solution if it's acid or alkali, so how you will know? You will use this indicator. For example, if you will add red cabbage, what will happen? The color, it will change from purple to red. The red cabbage, the color of it, it's purple. But when you will add it to a solution, if this solution, it is acid, the color, it will change into red. If the solution, it is alkali, so the color, it will change to green. You need to focus on these colors. Red cabbage, it gives red color with acid, and it gives green color with alkali. Then we have another example of indicator, which is litmus solution. It changes from purple to red. When you will mix it with acid, it gives red color. But if you will mix it with alkali, it gives blue color. Methyl orange, it gives pink with acid, yellow with alkali. Phenolphthalein, colorless with acid, and pink with alkali. Usually in the labs of school, what we use this kind of indicator. We call it litmus paper. Of course, you know what are the litmus papers we used in the lab. Litmus paper is frequently used. Blue, it means it's acid. Red, it means it's alkali. Now, the pH scale. pH scale, if you look at this is a scale, we call it pH scale. It shows the strength of acids and alkalis. We have acid, for example, we will say this acid, it's a strong acid or it's weak acid. But how we will know if it's strong or if it's weak? By using pH scale. How we will use it? The pH scale, also if you remember how you did it in the lab, we have pH test papers. We have papers, when you will put it in a solution, it will change the color of this paper. So then we have this scale. You will compare the color that you got with these colors. You will see it match with which color. For example, if it will gives red, okay, that's mean this is a strong, this it's a 0, it's 0 and 1, it's strong acid. Okay, then as much as you will move to the 7, okay, from 0 to the 6, this is for acid. 0, it's strong acid. 1, also it's strong, but the strength of it will decrease as much as we go to the or we will reach number 7. At 7, what will happen? Here we call it neutral. It's neither acid nor alkali. And the same thing it's here. From 8 to 14. 8, it starts being alkali. As much as we will move to this direction, to number 14, here it will be strong alkali. So 7, it's neutral. Then less than 7, 6 and below, it is acid. As much as the number will change, it will turn to be less, the acidity it will increase. And the same thing it is here. The 8, it's weak alkali, and as much as we will go to this direction, the alkalinity of it will increase. Now, when I said we use some of acids and alkali at home, let's take these examples. Toothpaste. Toothpaste, it's what? Toothpaste, it's an example of alkalis. Okay, toothpaste, we use it for cleaning the teeth. Okay, and also here lemon juice. Okay, and lemon juice, vinegar. Okay, all of this we use them at home. Then neutralization. Neutralization, it's a process. It's a process in which what will happen? The solution will turn to be neutral. For example, if you have a solution, it's acid, you will add alkali to it until until the pH of it will be 7. When it will be 7, now this process we call it neutralization. See, the general word equation for a neutralization reaction, it is, if you have acid and you will add alkali to it, what will happen? You will get at the end water plus salt. So when you will get water, the pH here, it will be 7. So this is the neutralization. Here are some examples from a school science laboratory. Hydrochloric acid, HCl, if you will add it to NaOH, which is sodium hydroxide, you will get salt plus water. So all of these are examples of the process of neutralization. Applications of neutralization. Here we have some example of applications of neutralization. I prefer if you will use the examples that you have in your science book, okay? Because that examples, it will be included for the checkpoint. But also I will explain this. For example, you have a bee sting. A bee sting, it's acidic and is neutralized by soap. So what will happen? Bee sting, it's acid. You will wash your hand or the area where the bee it stinged you. So what will happen? You are adding soap, which is alkali. Alkali plus acid, you will get water, okay, which is a process of neutralization. Another example. Here we have this example. Sodium hydrogen carbonate is used in tablet to cure indigestion when there is too much acid in the stomach. Uh, this case, I think it happens to everyone of us. Sometimes when you will eat too much food, or you eat too much different types of food, so then what will happen? The acid from your stomach, it will start going outside your stomach. It goes to your throat. So now in this case, what will happen? You will feel it's like burning your esophagus. It's like burning. Why it's like burning? Because of the acid from your stomach. So how to solve this problem? You will take some pills. These pills, usually, for example, we call them Gafixon. When you will take these pills, it's alkali. When it goes to your stomach, it will neutralize your stomach. So what will happen then? You will solve this problem. Check your understanding. Again, it will be your homework. Chemical reactions. Chemical reactions are taking place all around us and inside us too. Some take in heat, we call them endothermic reactions, and some give out heat, we call them exothermic reactions. Reactions, we can classify them or divide them into two types of reactions depending on the heat. Are they taking in heat or are they giving out heat? The ones that it will take in heat, we call it endothermic reaction. The one that when it reacts, it gives heat. This we call it exothermic reactions. Although most of the chemical reactions are useful for our bodies, for example, but it's still not all of the chemical reactions are useful. Some of them it's not useful. Let's take some example of reactions which are not useful. First example, some of the reactions which are not useful take place when oxygen reacts with fat and oil in the food. If you will put a food, any kind of food, a food that, for example, it has oil in it and fat, if you will put it outside for a couple of days, what will happen? This food, it will start reacting with the oxygen from the air, and then an oxidation reaction, it will happen. What do you mean by oxidation reaction? The chemical reaction that it involved oxygen in it. Okay, when this oxidation reaction will happen, it will makes the food smell unpleasant and inedible. So we will not be able to eat this food anymore. Another example of food. Now you know the cans. When you buy any kind of most of the kinds of foods that it's stored in a can, what they do, they put some antioxidant substances in it to slow the process of oxidation. An example, let's take chips or snacks. Okay, bags of snacks. Food like corn chips have nitrogen in them instead of oxygen, so the oxidation process does not begin until the bag is open. Chips, okay, now when you will buy it, you will see it's fresh. Why it's fresh? Because they add nitrogen gas to it. This nitrogen, it will stop the process of the oxidation. Once you will open it, then the oxygen from the air, it will go inside it, and then the oxidation reaction, it will start happening. Another example, which it's when you have a metal, if this metal, it will react with the oxygen, it will form metal oxide. Metal oxide, it's a scientific name of rust. For example, if you have a piece of iron, if you will put this piece of iron outside, after a period of time, what will happen? You will see a rust. It will start forming a layer of rust. It will start forming on this metal, on this iron. Okay, why? What happened? This is a chemical reaction. The iron and metal, it reacts with oxygen to form metal oxide. This metal oxide or this rust, it will make the metal weak. And still there are lots of reactions that are not useful. Now let's take some examples of endothermic reactions and also exothermic reactions. When we said endothermic reactions, it's a chemical reaction in which the energy or the heat, it will be taken in. How is that? If you have ice, when this ice it will start melting. Why it start melting? As we know, if the temperature is 0 and below, here we will have ice. But if the temperature it increase 0 and above 0, what will happen? The ice will start melting. Now this is what? This is an example of endothermic reaction, because here what happened? The ice, where it start taking energy, taking heat from the environment, from the surrounded environment, and it will start to melt. Another example, cooking. Cooking, if you want to cook anything, what you will do? You will put a pan on a source of heat, okay, oven. In this case, what will happen? For example, let's say you are cooking egg. Egg, firstly, it's like a jelly, okay, but when it will start taking in the heat, what will happen? It will turn to be solid, okay. So cooking is an example of endothermic reaction. Let's take another example of exothermic reaction. Exothermic reaction, we say it's a chemical reaction in which the heat, it will be given out, okay. What's that mean? How we can give the energy, give heat out? Simply, the simplest answer is what? By burning. An example of burning. When you burn anything, let's say if you burn a piece of paper, when you burn a piece of paper, what will happen? There will be a chemical reaction which is burning paper with oxygen from the air, and at the end, what will happen? It will give heat. So burning, it's an example of exothermic reaction. Another example, rusting. Rusting, we just explained it. Also, it's an example of chemical reaction and example of exothermic reaction. Respiration. Respiration, it's a process in which energy is released from glucose, okay, by using oxygen. Let's take another example. In summer, in summer it's hot. The weather is hot. In summer we cannot eat chocolate. Why we cannot eat chocolate? If you will eat chocolate, you will feel it's hot. Why? What happened? The chocolate that you ate, it was full of glucose, sugar. When you breathe in, the oxygen that you are breathing, it will break down the glucose that you ate, and it will release heat. That's why you will feel it's hot. So respiration also, it's an example of exothermic reaction. Exothermic, endothermic reactions, this is an important topic you need to know. You need to focus on the definition of each one, and also you should be familiar with the examples of them. Check your understanding, your task. Reactions of metals. Metals, it reacts with oxygen, it reacts with water, but metals, and also it reacts with acids, okay, but different metals react at different speeds when they react with other chemicals. For example, let's take oxygen. We have metals, some of the metals, it react fast with oxygen. Others, it takes a long time to react. So their reactivity, it differ. The reactivity of these metals, it differ when they react with oxygen. Let's take examples. Sodium. It bursts into flame and burns quickly to form a white powder. So if you will have sodium and you will just put in a place where there is oxygen, directly it burn. Okay, but if we will take iron as an example of metal, if you will put iron in a place where there is oxygen, a chemical reaction will happen that will form iron oxide, which is rust, but this process, it will take a long time. Okay. Copper does not glow or burst into flame. It forms black powder. Okay. Gold does not change. So as you can see here, we have different metals. When they react with oxygen, they react in a different ways. The same thing, it's water. Example, potassium floats and bursts into flame. Hydrogen is produced and potassium hydroxide solution is formed. Again, here we have different examples of metals when it reacts with water. Here it reacts very fast, but let's take another example. Copper. Copper does not react with water. Okay. Magnesium, zinc, iron. It will not react with water. Okay. But it will react with steam. Okay, so all of these materials, all of these metals, it react with oxygen and water in different ways. Reaction with dilute acids. It will react with acids. Also here, we have something we call it reactivity series. Reactivity series, it's what? It's a scale that it shows the reactivity of metals. We will see, we will have some metals, they are very reactive, so it will comes here. For example, potassium, sodium, calcium. As you can see here, these elements or these metals are arranged in a way depending on their reactivity. As much as you will go to the top, the reactivity, it will increase. Now potassium is the most reactive one and gold is the least reactive one, as you can see here. Potassium, when it reacts with oxygen, oxides form very vigorously. But if you will come to silver and gold, you will see here they will not react with the oxygen. So this is what they mean by reactivity series. Preparing salt. When you will hear the word salt, directly it comes to your mind the table salt. Okay, but in fact, it's not the only example of salt. We have different types, different examples of salts. Okay, how we can prepare salt? The way to prepare salt, what you will need metal plus acid. When you will have metal plus acid, okay, metal plus acid, you will get salt. So here we have some ways of preparing salt. Rates of reaction. Rates of reaction, what do you mean by rates of reaction? How fast or slow the reaction is. Now when I was explaining the reaction between, for example, iron with oxygen or potassium with oxygen, we saw some of the example of iron and oxygen. This chemical reaction, it happens, but it will take a long time. So this is what they mean by how fast or slow the reaction is. How we can measure the rate of reaction? How we will know this reaction is fast or slow? In each chemical reaction, what we will have, let's take this an example. We will have these substances that are here and these substances. This one at this side, we call them reactants. Reactants are the substance that it will react. When these substances will react, it will produce a new substances. The substances here, we call them products. So, how we can measure the rate of reaction? We can measure it by two ways. We will measure how much of the reactants it react during a specific period of time, or we will depend on products. we will measure how much products it produced during specific time. Now we will talk about the factors that it will affect the rate of reaction. We will see what are the things, what are the factors that it makes the chemical reaction faster or slower. Firstly, we will talk about concentration. Concentration, what do you mean by concentration? It means how much matter, how much particles this object it has. Okay? The concentration, or in chemical reaction in general, how it will happen? It will happen when the particles will start collide with each other. When the concentration, it will increase, what will happen to the rate of reaction? The rate of reaction also, it will increase. The explanation is when you will add more substances or when you will increase the concentration, you are adding more particles. More particles, it means depending on the particle theory, you will say higher concentration, it means more particles. More particles, it means the chance of colliding or the chance of collision, it will increase. When collisions, number of collisions, it will be more. That's mean the rate of reaction, it will increase, or the chemical reaction will be faster. Temperature. Temperature, also we will see how temperature it will affect on the rate of chemical reaction. Raising the temperature of the reactants, it speeds up the rate of reaction. How is that? When you will increase the temperature, that means you are increasing the energy of the particles. When the particles, it will get more energy, so it will start moving faster. When it will move faster, then the number of collisions, it will increase. When the number of collisions, it will increase, that means the rate of reaction also, it will increase. In your book, also you have more factors that affect on the rate of reaction, which is the surface area. Surface area also, as much as the surface area, it will increase, so the rate of reaction, it will increase. Explanation, you will say, when the surface area, it will increase, that's mean more atoms will participate in the chemical reaction. That means there will be more particles to collide. More collisions, it will increase the rate of the chemical reaction. Then, last thing, catalysts. Catalysts, what do you mean by catalysts? Catalysts are substances that it speeds up the rate of reaction without changing in its structure. Example. When you want to wash your clothes, okay, let's say there is a spot of oil or something on your clothes and you want to wash it. When you will wash it with water, this maybe it will go, it will vanish, or maybe it will not. What you will do to do this chemical reaction, what you will do to increase, to make this chemical reaction faster, you will add some, for example, maybe bleach, or any kind of things that use it for washing. This bleach, now it works as what? It works as a catalyst. Why? This bleach, it will speed up the chemical reaction. What's the chemical reaction? Making the spot of oil vanish. So when you will add bleach, then bleach or tide or any kind of this substances, what will happen? It will increase the speed. It will speed up the chemical reaction. And at the end, what will happen to the bleach? Nothing. It will not change. Its structure, it will not change. Tips for success. Remember that concentration, particle size. Particle size here, it's another meaning of surface area. Temperature and the presence of catalysts are important factors in determining the rate of a reaction. Check your understanding. It will be your task for this lesson. Dear students, that was everything for this unit. I hope everything it was clear. Again, when you will finish watching this video, please write a comment. If you have any questions, concerns, or any suggestions, please mention them. Again, thank you and have a good day.